hopefully a really quick video because I think I'm not going to be in class. I'm not 100% sure about that, but I'm pretty sure. Um, so the kind of three things that people might be working on are these three here. So the Ebola data practice we're pretty much finished with. The only one is that there's a question down near the bottom that I think is worth in F block. We didn't quite get to this. Um, and following up on some work that you guys did. So really, you should have some things for different ones, right? We just barely finished this one about the medication, but if everybody can at least try 1G, and then whether or not you turn this in, you can leave it not turned in, but when I get to it, this is the one that would be good for some people to practice to try to really get in like some of those vocabulary words, like antigen, antibody, um, B cells, receptors, like that would be something that would be worth trying, and that I'm specifically going to check everybody's for that. But mostly we're finished with that one. Again, it doesn't matter if you turn it in or not. I'll be able to see what you have either way. And then it looks like most people haven't quite gotten to this. And so kind of all three of these are about, kind of like study design, looking at data, and then what you might start on today is this, kind of like coming up with your own question and testing something about disease modeling. And so you're going to try to collect data in a controlled way and then produce a graph and analyze the data. And we're going to be working on that over a couple of classes, probably not past next week, but leading into next week. So this one is just kind of another idea, but again, like related to vaccines, I would like people to understand, and I think a lot of people do, but looking at this study to test, actually it's this one, to test the BioNTech Pfizer vaccine, which is this is the name of it, BioNTech. So some of the things, and hopefully from that last question, like we talked about, like what's an independent variable, right? What the researchers or the investigators have changed. The dependent variable is what you're measuring. And then the controlled variables, like when you think about these people that were taking the vaccine, what about the people themselves, but also the way that the study was carried out were controlled, done the same way for every single person. So it's not a super complicated study, but if you just read through these methods, I think you're going to get some ideas about what things they've controlled. So again, like it's not super long, it's not super complicated. Mostly you can, read through a little bit about this, but mostly you're going to be looking at this one graph, which I've also included in your, the copy of these questions that you have. So it doesn't have to be like a full written answer, but, and some of these are just, stating what the variables are, listing some controlled variables, describing, so a lot of times when you evaluate a study, the strengths are often controlled variables, but was there anything else that they did that would be considered a strength? So mostly you're just kind of getting an idea of what do they do here. And then for the graph, you're looking to compare and contrast these two groups, and then explaining the reasons. And this is kind of a really similar thing that you did for some of those Ebola questions. Some was just picking information out of a graph, but then, to explain it, you need to have some knowledge about immunity and how that works to be able to do that. Okay, so the last thing that people can start on today, I've put a couple of different simulations up here that you can use to model disease spread. And so I was trying to get something that you could manipulate, collect data, produce a graph, and then eventually analyze. I think most of you guys, well, if you're EAB, I think you used Gizmos last year. What you should be able to do is if you go to the student login, there's a class code, but you kind of have to pretend like you're going to log in to get to the point. So you can say my username, and then there should be this student class enrollment. So this is where you're going to put the class code. So it's right here, DLDCWH. And you can either link that to the Gizmos account that you might have made last year, or you can make a new one. So on there's this Gizmo that shows, and this one's probably the simplest model of disease spread. And you don't necessarily have to like fill out anything. You're just looking at, what can this model measure? And then you're sort of thinking about, is there a variable, an independent variable that you would like to test? So you can kind of, I would today go around and play around with the different models. If you have a specific question that you are interested in testing, you can go ahead and start setting up kind of your plan for how you're going to test for this variable. So, but you can see like you can change the number of people. You can change the disease type here, probability of transmission. There aren't as many things that you can change in the gizmo, but you can kind of simply see here that if you press play on this, you can look at this, just numbers over time, but you can also look at this graph over time. And so, and you've got like, over hours. So what I want people to kind of think about is, what is an interesting question that you would test to test something about disease spread? And there are some things that are going to be kind of obvious about disease spread. So is there an interesting question here that you would like to explore? And I want to just challenge people who, pick a question that's at your level of, like you think this will be a bit of a challenge for you, but not, not too hard, but not too easy either. So if I were you guys, look at these other three. So NetLogo, it's done through Northwestern University, but it's a similar idea where you can change certain variables, you can test, how a disease might spread over time, but you're going to see that some of these are more complicated than others. So for any of these models, you can kind of read through, okay, what is this model? How does it work? Some things that are built into the model. But then what you can do, is just sort of, if you set up, you can change some, how many people am I talking about? How infectious is this pathogen? What's the chance that somebody recovers? So something like, well, I'm interested to see what this, but something like Ebola versus something like COVID, right, are going to have really different chances of recovery. And then duration, I'm not sure if this is the duration of but it might be the duration of the illness. So I would, before you come up with a question, you kind of want to have an idea about how the simulation works. So what you're trying to do by next class, you might not have your entire investigation planned out, but I would feel like, the simulation that you might use, do you understand how it works? And so you can press go on this, and you can see that this graph down here will collect data over time. So number of weeks, and then you've got numbers of, those are your total people, these are your healthy people, these are your immune, they've had the disease and recovered. And you can see that at any time point, like here's at 106 weeks, I have 13 immune people, and you can also see them in your simulation over here. So there are, I think all of these will be good, but I think probably the most complicated one, I'm going to actually stop this. Eventually what you're thinking about is that you can read data from the graph. So what are you interested in measuring? Are you going to be looking at the number of sick people over time? Whatever you change. So your question might be, I want to change the infectiousness and see what effect that has on the number of ill people over time. So again, like this is going to leave some people the ability to, make a question and do some data analysis at the place that they're at. So we can talk about how you actually collect data. You can collect data off the graph and make a data table. Or if you feel like you're pretty good at Excel, you can also, I think it's here, you can download the Excel file, and the CSV you can re-upload to Google Sheets to play around in that. You can use a ton of this data to, to answer a more complicated question or to see a more complicated pattern. But there's different levels of how you'll be able to do this. So today you really want to get towards what might be your question, how are you going to collect data, but also how will you control what makes sense for the number of people to use. If you're changing infectiousness, you would want to keep the number of people, the chance of recovery, the duration the same so that you're just measuring that variable, but you're going to want to think carefully about what variables will you use for these other, if you're going to control them, what number makes sense to use as the controlled variable. So there's going to be a little bit of this that is, how do you set up a study or an investigation, and then next week we'll collect the data, we'll graph the data, and try to explain that using what we know about pathogens. So feel free to poke through these. The most complicated one is probably this travel one. There's a lot of different things that you could change in here, but you're trying to pick out a question that, is challenging but is not insane. So I would it's like initial ambulance. I don't know what that is, but you can go down here in the model info and it should be able to explain what some of these different things are. But feel free to, to play around with these a bit and pick a question that you think is really interesting. But we'll talk a little bit next class about how to set up a data table and how to get everybody going on collecting data. But if you feel like you're ready to go, attach a Google Sheet to the assignment and you can start working in there. This assignment is going to move from, right now it doesn't have a due date, but it will eventually move to a formative, and then it will be a summative investigation. But there will be some supports along